This is Ahead with Logos Learning, and in this video I will be discussing two types of chemical reactions, synthesis and decomposition. Now, what is a synthesis reaction? The word synthesis means to make. Synthesis reactions are chemical reactions in which elements or compounds combine to form new substances. So here we have chemical or compound A plus B makes a combination AB. So we took two blocks and we built something that is composed of these two blocks. Now let's take a look at a few examples. First example here we have rusting, or sometimes called the combustion of iron. So we have iron 3, and iron 3 reacts with oxygen, and this makes iron oxide. So let's write down what iron oxide is. Iron is Fe3+, because iron is what we call a multivalent ion, which means it can have a charge of +3 or +2. So here we specify as the +3. So we have iron +3, and we have oxygen -2. So when you write down the formula of a compound, you always crisscross, so this becomes Fe2O3, or rusting. Now just for practice, let's balance this. We have one iron here, we have two irons here, we have 3 oxygens here and 2 here. So I'm going to work on the oxygen first. Here we have 3, so I'm going to put a 2. And here we have 2, so I'm going to put a 3. So now there is 6 and 6. Now we have 4 irons, so we're going to put a 4 here. And this is how we balance the equation for rusting. Another example for synthesis, we have hydrogen gas plus oxygen gas. That makes water. It is water synthesis. Now let's balance it. We have 1 oxygen here and 2 here, so let's put a 2 here. We have 4 hydrogens here and then 2 here, so let's put a 2 here, and it's all balanced. So as you can see here, we have one compound and another compound, and we make something that is comprised of both of them. Salt formation. So salt is not always NaCl. NaCl, sodium chloride, is table salt. Any ionic compound can be referred to as a salt. So here we have potassium and chlorine, and that's going to form potassium chloride. But to write the formula for potassium chloride, K is normally +1 and Cl is -1. Don't look at the 2 here. This 2 means that it is the molecular form of chlorine, okay, or chlorine gas. So here we're going to do the crisscross again. Metal goes first, K1, Cl1, and we don't have to write the 1s because it's just unnecessary. Whenever there's nothing, just like math, whenever there's nothing, there's a 1. It's implied. Now let's look at a few rules, because sometimes you don't know what these compounds make when you put them together, so we have a few rules. If you have a non-metal oxide, SO2, sulfur dioxide, so here you have non-metal oxide, okay, plus water, it's going to form the ic oxyacid. So this is sulfur, so it's going to form sulfuric acid, H2SO4. Okay, so normally teachers give you a periodic table. On the back of the periodic table, they have all of the oxyacids. They're all listed in the ic form, H2SO4. So let's say we have CO2, so carbon dioxide plus H2O. So if the sulfur forms sulfuric acid, what do you think carbon is going to form? It's going to form carbonic acid, H2CO3. Alright, let's move on. If you have a metal oxide and water, that's going to form the metal hydroxide. So metal oxide, like magnesium oxide, this is the metal oxide, plus water forms a metal hydroxide. So don't forget, hydroxide is OH -1. Magnesium is 2+, and hydroxide is 1-, so we're going to crisscross. This becomes MgOH, but 2 OHs, because the 2 goes down. So we're going to put brackets around the ion and put a 2 there. Alright, let's move on. Metal oxide plus carbon dioxide forms metal carbonate. So metal oxide, so MgO, that's magnesium oxide, plus carbon dioxide forms the same metal, so Mg carbonate. Carbonate is CO3, 2-. So Mg is 2+, CO3 is 2-, so whenever you do crisscross, it becomes Mg2, CO3, 2. So since they're both 2, you don't get to write it. So just MgCO3. Now, let's move on to decomposition reactions. Now, a decomposition reaction is basically the inverse of synthesis. Synthesis means to make, decomposition means to break. So a decomposition reaction is a chemical reaction in which a compound breaks down into elements or other compounds. So we take a block and we break it. It's like Lego. We just decompose it. An example of that is waterlysis or electrolysis, sometimes they call it, because the breaking of water requires electricity. Now, take water. In the other reaction, we took 2 hydrogens, or hydrogen gas, oxygen gas, to make water liquid. Here, we're going to do the opposite. We have water liquid. We're going to break it down to hydrogen gas plus oxygen gas. When I say gas, I just mean that I write a 2 here. Alright, so let's balance this. We have 1 oxygen here, 2 here, so let's put a 2 here to balance that. Now this results in 4 hydrogens. We're going to put a 2 here. Now we have 4 hydrogens. And just a side note, I hope you guys remember the Hofbrinkel. Okay, so all of these elements, hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine, all of these, whenever they're in the gaseous form, in the natural form that we find them on Earth, they're always diatomic. Diatomic, that means they come in 2s. H2, whenever you find it, H2, O2, F2, Br2, and so on. Okay, so don't forget that, it's important. Now, let's look at an example of decomposition in a reaction. Then we have the decomposition of baking soda. Now, baking soda is sodium bicarbonate. Whenever you have an H here, it's a bicarbonate. Now, we give the baking soda some heat, and the baking soda is going to break down to sodium carbonate, water, and carbon dioxide. You don't have to memorize this. This is just an example to show you that in decomposition, a compound breaks down to components. Now, let's look at some rules. The rules here are basically the inverse of the rules for the synthesis reaction, and I really suggest that you guys take a cue card and write all these rules down just for while you study, just to memorize them while you study and practice with them properly. Now, we have a metal carbonate. A metal carbonate will decompose to form metal oxide and carbon dioxide. Let's see. Sodium carbonate. So our metal here is sodium. Now, when this breaks down due to heating, it forms the metal oxide. So the metal that we have is Na, and it's a plus. Oxide, O is 2 minus. So whenever you want to write down the metal oxide for sodium, it is Na2O. It's very important to do the crisscross properly. Carbon dioxide, it's always CO2. Let's balance this. Oh, it's already balanced. Great. Now, if you have a metal hydroxide, like potassium hydroxide, this decomposes to metal oxide and water. So our metal is K, oxide is O, so K is plus, O is 2 minus. When we crisscross, it becomes K2O. You need to do this because how can you memorize that metal oxide for potassium is K2O and not just KO? So always keep this in mind, the charges. Plus water, H2O. Is this balanced? No. Let's put a 2 here. So 2 Ks, 2 Ks. 2 oxygens, 2 hydrogens. It works. Now, next. If you have an oxyacid, ic form, these are the acids that you find on the back of your periodic table. When that decomposes, it forms a non-metal oxide and water. So here, what is a non-metal oxide for a carbonic acid? It is CO2, non-metal oxide, and H2O. Let's try to balance that. 2 hydrogens, 2 hydrogens, 3 carbons, 3 carbons. Perfect. Next, metal bicarbonate. We decompose that to form metal carbonate. So don't forget the carbonate is CO3, 2 minus. It's a polyatomic anion. Polyatomic means it has more than one atom. So this is polyatomic as opposed to Cl minus, which is an anion made only of chlorine. One atom becomes ionic. Here we have 4 atoms that form this ion. Now, metal bicarbonate forms metal carbonate, so our metal here is K, potassium, and carbonate is CO3 2 minus, potassium is 1 plus. So whenever you do the crisscross, the 2 from the carbonate goes on as a subscript for the potassium, and the 1 from the potassium doesn't have to be written. So potassium carbonate plus water plus carbon dioxide. Now let's see. 1 potassium, 2 potassium. So let's put a 2 here for now. We have 2 hydrogens. We have 2 hydrogens. Works out. How many carbons? 2 carbons. We have 1, 2 here. Great. 6 oxygens. So we have 3 here, 2 here, and 1 here. So that's 6. Perfect. It is balanced. So I hope that this video helped. And in my next video, I will be talking about single displacement reactions, and the one following that, it'll be double displacement reactions.